Hello, my name is Kai, and in this lesson, we will create a weather forecast project using your Arduino Sensor Kit. A weather forecast is used to predict the conditions of the atmosphere. In this project, we will be using the air pressure sensor and the DHT temperature and humidity sensor. These values will be displayed on the OLED display. First things first, prepare your Arduino Sensor Kit and connect it to your Arduino Uno. Then, connect your Arduino Uno to your computer using the Arduino's USB cable. Open your Arduino IDE and proceed to create a new sketch. Then, we will include the Arduino Sensor Kit library. Next, initialize the OLED display by typing in OLED.begin in the setup function. Next, set the OLED display orientation position by typing in OLED.setFlipMode true. Now, we will set your OLED display font type by typing in this code in the loop function. Then, we will set the OLED display cursor to the first column and the first row. Next, we'll proceed to print the header on the OLED display on the first line, which is weather forecast, by typing in this code. Next, we need to update the OLED display for new values by typing in OLED.refreshDisplay. Next, we will set a time delay when running the main function again. We will create a variable called delay time that is set on 1000 milliseconds. Next, click on upload and it will proceed to save your new sketch. For this example, we will be naming it weather forecast and then click save. Wait for it to compile and upload to your Arduino. Once it's done uploading, check your OLED display and check the display on the first line, which should be weather forecast. If you encountered any problem, make sure to select the port of your Arduino device and its Arduino board. Then let's proceed to initialize the air pressure sensor by typing in pressure.begin. Now let's create a function that acquires the sensor's data. We will create a variable for temperature, air pressure, altitude, and humidity. Get the value of the temperature from the air pressure sensor using pressure.readTemperature and set it to a temperature variable by typing in this code. The value acquired from the air pressure sensor is already in Celsius. Next, get the value of the air pressure by typing in pressure.readPressure. The value acquired by the air pressure sensor is in Pascal. For this project, we'll convert it to hectopascal. Next, get the value of the altitude by typing this code. The value acquired from the air pressure sensor is already in meters. Then, let's call the function in the main loop by typing in this code. Next, we'll create another function that displays the temperature. In this function, we'll print the temperature on the OLED display. In order to do this, first, we're going to set the cursor on the second line by typing in this code. Next, we'll print the label of the temperature. Then, we'll print the value of the temperature. Next, we'll print the unit of the temperature, which is Celsius. Now add the display temperature function in the main loop. Then upload it to your Arduino. Check your OLED display and it will display the weather forecast header and the temperature value. Now let's proceed to display the remaining sensor values, the air pressure, and the altitude. We'll create a function which displays the air pressure to your OLED display. Inside this function, we'll set the cursor of the OLED display to the third line. Next, print the pressure label. Then print the air pressure value. And then print the air pressure unit, which is in hectopascal. Now let's create another function for displaying the altitude to the OLED display. In this function, we'll set the cursor on the fourth line. Next, print the altitude label. Then print the altitude value. Afterwards, print the altitude unit, which is in meters. Now let's go back to the main function and add these two functions, the display pressure and the display altitude, in order to display the sensor data. These should be displayed after the getSensorData function. After adding it to the main function, proceed to upload it on the Arduino board. After uploading, check your OLED display and see if the weather forecast header, temperature, pressure, and altitude values are there. Next is to get the humidity value from the DHT sensor. First, we need to initialize the DHT sensor by typing in environment.begin. Then create a function that displays humidity on the OLED display. Go to the function getSensorData and add a variable to read the humidity values. Next, go back to the display humidity function and add a line of code to set the starting cursor to the 5th line. Next, print the humidity label. Then print the humidity value. Then print the humidity unit, which is in percentage. Go back to the main function and add the display humidity function. This must be set after the get sensors data. After adding it to the main function, proceed to upload it to the Arduino Uno. After uploading, check your OLED display and you can now see the weather forecast header, temperature, pressure, altitude, and humidity values. These next codes for the weather forecast prediction will be using the Zambretti algorithm. It is based on an instrument developed by Negretti and Zambra. The code will be based by existing GitHub library by Fundonov. First, we need to record time since boot or the start of the program. We will create a getTime function. Add the current time variable since program run in seconds, minutes, and hours. Get the time in milliseconds and convert it to seconds. Then get the time in milliseconds and convert it to minutes. Then get the time in milliseconds again and this time convert it to hours. Add the getTime function in the first line of the main function or before the set font. Next, proceed to create the displayTime function. This function is to display the time value since the program has been run to the OLED display. Set the OLED cursor to the 6th line. Print the time label. Print the hour value and add an if statement that if the values are less than 10, it will add 0 before the first digit to have a uniform 2-digit number. Next, print the minutes. Then, print the seconds. Go to the main function and add the displayTime function. Just make sure to add it after the getTime function or below the display humidity. Now upload it to your Arduino device. So now, you should be able to observe the time on your OLED display, which is in hours, minutes, and seconds. Next step is to create a getCPressure function. This function will convert the current air pressure to sea pressure. Add a condition on the getCPressure function that makes sure that it will run every minute, or if isCalibDoneSec variable is set to true, then this will keep running and store every second for fast calibration. Add this variable to store the last recorded minute when sea pressure is stored. Then add isCalibDoneSec variable as boolean. Set this variable to true if you want to have much faster calibration in seconds. Set it to false if you want to have more accurate prediction in minutes. The best calibration will be in hours, but for this project, we will limit our calibration to minutes and seconds. Add the sea pressure variable as a float. This variable is to store the sea level pressure from converted air pressure. Now we'll create a station to sea level function that converts air pressure to sea level pressure. This also needs other parameters like height and temperature. Call the station to sea level function and set the sea level pressure to sea pressure variable. Check if the sea pressure store counter is at maximum. This code will set the doneCalibForecast variable to true so that it indicates that it's already done calibrating. Done calibrating means it's recorded maximum sea level pressure. Add the doneCalibForecast variable to identify if the recorded pressures are at maximum records. Next, this line of code will arrange the sea pressure array variable so that it will remove the first recorded sea pressure and insert the latest recorded sea pressure. Then this line of code will insert the latest recorded sea pressure. Add the sea pressure array variable. This is for storing the sea level pressure in an array. Next, if the recorded pressure counter variable is not on maximum value, we'll insert the sea level pressure to the sea pressure array. Next, increment the recorded pressure counter. Then, call the getDisplayForecast function and we'll add to it later. Then, record the minute when the sea pressure is stored. Go to the main function and call the getSeaPressure function after the getSensors data. Go to the displayPressure function and replace the air pressure value by commenting it out and replace it with sea pressure value. Next, create the getDisplayForecast function, and in this function, it handles the forecast prediction algorithm and displays the forecast prediction to the OLED display. This line of code is for checking if the calibration forecast has already been done or not. Call the function displayForecast and pass the variable calibration for it's still calibrating. Next, create the function displayForecast that needs the weather type value. This will display the forecast to the OLED display. Next, we will add weather forecast types. First, define the calibration type. This is when the calibration is still calibrating. The 0 will be an integer ID that the display forecast will be using. Next, define the weather type sunny with an ID of 1. Next, define the weather type sunny cloudy with an ID of 2. Next, define the weather type cloudy with an ID of 3. Next, define the weather type rainy with an ID of 4. Next, define the weather type thunder with an ID of 5. Go back to the display function and add line to set OLED cursor to the 7th line. Add this code to clear the 7th line for the previous values. Add a switch type condition for checking the weather type. Add a switch case for calibration of weather type, then print its label to the OLED display. Add a switch case for the sunny weather type, then print its label to the OLED display. Add a switch case for the sunny cloudy weather type, then print its label to the OLED display. Add a switch case for the cloudy weather type, then print its label to the OLED display. Add a switch case for the rainy weather type, then print its label to the OLED display. Add a switch case for the thunderstorm weather type, then print its label to the OLED display. Then go back to the getDisplayForecast function. If the stored pressure is at maximum, calculate for the forecast number, which is variable z. Then create a function that calculates using the Zambretti algorithm with a parameter of current pressure, previous pressure, and current month. The current pressure will be the average of the three latest readings of the sea level pressure, and the previous pressure will be the average of the three last readings of the sea level pressure, and the current month, which is January, with a value of 1. As you can observe in the website, these are the designated forecast number for each weather type. This consists for rising, falling, and steady sea level pressures. Check if the current pressure is falling and the current month is in summer. If the current sea level pressure is greater than 1030 HPA, it will return number 2 forecast, which is fine weather. Next is for the condition if the current month is winter. If the current sea level pressure is greater than 1030 HPA, it will return number 2 forecast, which is fine weather. Now check if the current pressure is rising and the current month is in summer. If the current sea level pressure is greater than 1030 HPA, it will return number 1 forecast, which is settled fine. Next is another condition for if the current month is winter. If the current sea level pressure is greater than 1030 HPA, it will return number 1 forecast, which is settled fine. Next, we're going to add a condition for if the current pressure is steady. If the current sea level pressure is greater than 1030 HPA, it will return number 1 forecast, which is settled fine. Check if there's a syntax problem by clicking the Verify button. Oops, I forgot to add the recorded pressure counter variable. This variable is to count the recorded sea pressure, and it has a maximum of 10 recorded sea pressures. Fixing the parenthesis syntax issue. Also forgot to add the month now variable. Set this variable to your current month in number format. For example, in this sketch, we're gonna set the current month to January. Now back to the getDisplayForecast function, we will summarize the number forecast and set the specified weather type to be displayed to the OLED display. To determine the rising sea level pressure, it is done by calculating the sum of the 3 latest sea level pressure recording and subtract the 3 last readings. If the difference is greater than or equal to 3, then it is rising. If the number forecast is less than 3, set the weather type as sunny. If the number forecast is greater than or equal to 3 and less than or equal to 9, set the weather type as sunny cloudy. If the number forecast is greater than 9 and less than or equal to 17, set the weather type as cloudy. If the number forecast is greater than 17, set the weather type as rainy. To determine the falling sea pressure, calculate the sum of the 3 last sea level pressure recordings and subtract the 3 latest recordings. If the difference is greater than or equal to 3, then it's falling. If the number forecast is less than 4, set the weather type as sunny. If the number forecast is greater than or equal to 4 and less than or equal to 14, set the weather type as sunny cloudy. If the number forecast is greater than or equal to 14 and less than 19, set the weather type as thunder. If the number forecast is greater than or equal to 19 and less than 21, set the weather type as cloudy. If the number forecast is greater than 19, set the weather type as rainy. Now for steady sea pressure where there is no changes. If the number forecast is less than 5, set the weather type as sunny. If the number forecast is greater than or equal to 5 and less than or equal to 11, set the weather type as sunny cloudy. If the number forecast is greater than 11 and less than 14, set the weather type as cloudy. If the number forecast is greater than or equal to 14 and less than 19, set the weather type as thunder. If the number forecast is greater than 19, set the weather type as rainy. Then we're going to be fixing some syntax problem. After fixing the syntax problem, upload it to your Arduino device. Then as you can see on the 7th line, the first 10 seconds will be calibrating. If the variable isCalib.sec is set to true. If not, then it will be the first 10 minutes. Then it will change to the calculated weather forecast.
Now that is it for this lesson. To learn more about the other modules, simply head on to the next video.